So I'm Candace Shively with Utah State University Extension. I want to thank all of you for joining us. Adria Wheaton and myself are the ones organizing these monthly webinars, which we could not do without the support of Mark and E-Extension, as well as the support of Utah State University's Center for Water Efficient Landscaping. So we hope you've been enjoying these and finding them beneficial. Today we have Bernd joining us from New Mexico State University. Bernd Leinauer from New Mexico State University. Bernd is a professor and extension turfgrass specialist at New Mexico State, where he focuses on developing water management strategies for turf areas aimed at reducing the amount of water used for irrigation. Strategies include screening for low water use, cold and salt tolerance, and subsurface irrigation. And today he's going to focus on the subsurface irrigation side and cover some of the frequently asked questions about the install and its use in turf, as well as research findings associated with the water use. So again, if you have questions, please use that Q&A box. We'll do our best to answer those as we go along, and I'll turn the time over to Bernd.
Hello, everybody. So yeah, my name is Bernd Leinauer. I'm a turfgrass extension specialist here at New Mexico State University, and I will walk you through some of our research findings and some of the technologies out there as it relates to subsurface irrigation for turf areas. Now, we live in the desert Southwest where rain is very infrequent and not a whole lot, yet we have high ET demand for our plants. ET, that means evapotranspiration. So, and that is water lost from plant and soil surface. So that puts us in kind of a bind, because living in the desert with not much rain, but having plants that require significant amounts of water is actually almost it's difficult to deal with. As we look at our dark green line here based on ET, evapotranspiration, we're looking at about 50 inches of water per year as to water demand, and that's just based on the plants that we're growing. And when we look at the warm season grasses, we have about 40 inches, yet about 10 inches or less are met, and that's the dark blue line down here. That's our rainfall. In most of the years, we don't even get those 10 inches. We actually have 8 inches or less. So that is a significant amount of water needed for irrigation, and therefore water conservation is on our mind, as we would love to enjoy our turf areas for exercise, for sports, just for aesthetics. Here, of course, that was in inches. That's just a water column based on the ground. But if we convert that to a surface area, if we're looking at 1,000 square feet or 1 acre, you have the numbers here. So for warm season, we're looking at about 23,000 gallons per year, and cool season just over 30,000 gallons. And that's only for a 1,000 square foot area. If we scale up to 1 acre size, we have between 3 and 4 acre feet of water for that acre. And that is a significant number. That puts turf in the headlines. Turf is perceived as water guzzling ground cover, and there is a lot of programs out there that actually pay the homeowner money for turf removal and go CIRIG landscaping or some other low water use landscaping. Now, on top of these numbers that I've listed here, we actually see in the desert, we see much higher water use numbers, which just puts us in the bind even more. So there is a lot of strategies being discussed, what we should be doing in a desert landscape in order to conserve water. And the topic of today is, let's look a little bit about our irrigation systems and what can we do with maybe using different irrigation systems that are more efficient and that improve water distribution. And let's see if we can conserve amounts of water by not just changing the landscape entirely and going different ground covers, different plants, but keeping our grass, our turf areas, but irrigate more efficiently. So when we look at inefficient irrigation system in the landscape, we have two areas here. First of all, we have inefficient water distribution on the turf grass itself. We always see these concentric dry areas here. The lower picture shows that very nicely. Obviously, something is going on with our irrigation system. It's not distributing uniformly the way it was planned and installed. We also have dry patches here, and we have dry patches here in the upper left corner. Then not only do we have this visibly, we also have irrigation systems, sprinkler irrigation systems deteriorating, losing performance in time. This is one of my favorite slides that I use in my presentation. So we have here in the upper left corner, we have here an athletic field that was installed in 2004, 2005. We have near perfect coverage, but as we move in time, clearly the system doesn't operate efficiently anymore, and 6 years later we have these circular patterns, concentric rings in the middle of our field, and the first reaction always is, oh, I have dry areas, I need to increase my run time. Only later that we also focus on the irrigation system itself. So how do we do this? How do we check out our irrigation system if it is still distributing uniformly? And that's by an irrigation audit. Here we see a photo with our master gardener where we go out and teach workshops how to do an irrigation audit. And the result of such an irrigation audit is that we learn about how much water is actually put out by the irrigation system, not just how much is the spec sheet on the sprinkler or is listed on the spec sheet. We learn actual water use, and then we also learn about how evenly water is distributed on the turf area itself where we place the catch cans, and that is a number that we then calculate and is given as DU, or distribution uniformity, and in a landscape, in a turf area, should always be greater than 0.7 or 70%. That is the number that we aim for, because this number is important as it goes into our irrigation water requirement, into our calculation. We have ET, evapotranspiration, that gives us the genetic demand of the plant. We have our crop coefficient, our adjustment factor for our specific plants, and then we multiply this with ET, and then we divide it by distribution uniformity. So meaning we adjust our irrigation runtime based on how uniform the system is, and the lower the DU is, the more water needs to be applied. So there was a study a few years back published by Mechem in 2004, and he reported an average DU of 0.5. What that means in scheduling irrigation is that now the irrigation water doubles, and that has nothing to do with the plant stand itself. That is really only an adjustment for an irrigation inefficiency. So the irrigation amount doubles compared to really what the grass plant needs in order to maintain adequate quality. And this is really what we see here in New Mexico and in some other parts of the desert Southwest, what puts turf in the bind. It is inefficient irrigation system, and that DU that we have to adjust for these dry areas. Now, the second issue that we see in turf areas is water that is being sprayed on areas outside the turf itself, and it actually never reaches the grass. However, if we were to meter this turf area, all this water accounts towards use of grass, and this is an even greater issue, at least in our experience, that we have sprinkler systems designed and sprinkler system put in place that overspray, that our turf areas just don't don't meet the pattern that a sprinkler provides. So we have an even greater issue, greater losses here in water. And that again contributes to that perception that turf is a high water use crop, because it's so hard to irrigate uniformly and efficiently. And you can see this on these photos. So an alternative to the sprinkler systems that we see wildly in the landscape, particularly when it comes to turf, we have a second type of system to apply water, and this is what we call micro irrigation system. And within these micro irrigation systems, we have here on the right side, we have what's called sub irrigation system, and on the left side we have drip irrigation system. And I just want to go through these two approaches here in my presentation. So let's talk about these sub irrigation systems. These are usually line source systems that are about 12 to 16-inch deep. We irrigate and drain through one pipe system, and then the subgrade is usually sealed by a plastic barrier. And there are several companies on the market. There is the PAT system, the Cell system, and also the EPIC system. EPIC system right now most widely used. I mean, none of these systems is very commonly used, but of this little use, we see EPIC about widely used. Here you see such a system on the at the bottom. So you have a plastic liner, you have these drain tiles that at the same time also irrigate. So you not only remove water through these tiles, you actually also have a hose going into these tiles and then also feed and into the tiles, and then water is distributed evenly in the root zone, and through capillary activity is distributed, and then waters the plant stand. You can see this on the bottom right photo here. You see here a cell system green on a golf course where the approach area is not irrigated, but the green itself is irrigated. So we have here a drought stress grass, and here we have an irrigated grass. Similar system mainly used in athletic fields, the so-called PAT system, or prescription athletic turf, where we now distribute water through a pump system. So we pump water into it and also remove it. But again, we have the plastic liner, and then we fill this with the root zone, and here we have an athletic field. The base of an athletic field where this PAT system was installed. Now the last one is ECS EPIC system that was invented by an engineer in Reno, Nevada, where he uses a similar approach. Don't want to spend too much time here, where we have these trays in again at the base of our green tee athletic field, you name it, and all these trays are connected. So these trays will fill with water, and then through the connection actually flow over into the next one, fill the next one, and this is how you irrigate those areas from the bottom up with this EPIC system. You can also remove the trays. There was concern that there's a lot of plastic that you use to seal the ground. So they've actually removed these trays. They still kept the center parts that are instrumental in delivering the system on along the base. This was an athletic field somewhere in California. And again, the one system used for irrigation and for drainage if you have excess water in the field. We have some golf greens in the country that are built with these EPIC, and then also there is a subdivision in Nevada, I believe, where they have this EPIC system installed, and it is used for irrigation. Now, about 12 years back, we had a research project that was funded by United States Golf Association, where we compared several of these systems. We have a subsurface drip system. Here we have the EPIC system. Here we have, on the upper left corner, we have a sprinkler system, traditional sprinkler system. And we compared these systems over a period of 3 years. Again, funded by USGA. Also, irrigation systems were on board, supported our study, and it was maintained as a golf green. And over 3 years, we measured water use, drainage losses, turf quality. We investigated quite some parameters on this study. So we had what's called the USGA sprinkler system, the 12-inch with the drainage system, the root zone, peat amended, and then sprinkler irrigated. We have here on the right here, we have the same root zone USGA, but drip irrigated. And here we had that sub-irrigated plot, which was on straight sand and had the ECS system in place. In summary, this has been published. There is on the USGA website. Our research summaries are posted. Over the 3 years, we saw that the sub-irrigated turf showed significantly higher quality. We had less localized dry spots. You could actually see that on this photo already, where the sprinkler on the peat amended, you see already the dry spots developing, whereas ECS was soil moisture uniformity in the soil was much greater here compared to here. And this actually led to less localized dry spot. And on average, for the 3 year, we saw on sub-irrigated turf between 40 and 50% less water. We had the research committee come out, and they all looked at it very interesting, and there were good questions about it. The findings were, in our opinion, were obvious that sub-irrigation has the potential to provide significant water savings, but the technology still hasn't gone anywhere over the last 10 to 12 years. So that much for sub-irrigation as one alternative to sprinkler irrigation. Now, I'm interested here. I'd just like to ask that question. How many of you have actually ever heard of this sub-irrigation technology for turf areas? So if you would, please take that poll. We'll only take a few seconds. If you have heard of it, say yes. If you've never heard of it, say no. And if you may have heard about it a little bit, but really not in detail, then it's your third option here.
Okay, we'll just take another few seconds. Okay. All righty. And Bernard, are you able to see that?
Yeah, I see that.
Okay.
Okay, well, that's good. Thank you. Okay, so let's talk about subsurface drip irrigation, because that's really where we spent a lot of efforts and quite a bit of research over the last 10 years now, particularly as it relates to turf areas. So we are on the other side of this micro irrigation approach. Now, subsurface drip or drip irrigation in general, as a technology, has been around for quite some time. It started in Israel in the late 50s, early 60s, particularly for vegetable production, for food production, in greenhouses, and then has escaped, if we may want to call it that way, into the landscape, and it's widespread in the general landscape as it goes to native grasses, your flower beds, your shrubs, even on vegetable gardens. We see it. We also see it in production agriculture, in row crops, in field crops. There is a ton of data available how all of these crops and these plants can be grown at a higher quality, at a greater biomass with significantly less water than any of the overhead irrigation. However, the technology hasn't really taken off in turf. And that, to us, that was odd and interesting at the same time, because the companies do provide equipment. I put here the top 3 companies. On the top left, we see Netafim, Toro, Rainbird. They all have equipment available that can be placed in turf, below the turf surface, and can be used to irrigate turf areas. And the main benefit really here is that with this type of irrigation, you can irrigate exactly the area that needs to be irrigated. So you don't have to work with full circle, part circle, half circle, and try to put these sprinklers together to irrigate your turf uniformly. Now here is another Hunter also came on board a few 2 or 3 years back, and they actually have the drip line placed in some kind of a fleece. So the drip emitter places the water in the fleece, and then through the fleece the water wicks uniformly over the entire area. So this is Hunter EcoMat, and then we also have a product by the name of KISS, where we also, this is an Australian product, where we have the drip emitter and then the drip line here in the middle, and then 2 inches outside of the drip line we also have a fleece material, and it's supposed to irrigate more evenly and more uniformly along the drip line. So we've started working with this drip irrigation. We put out several studies over the last 10 years. Some of you may have read some of our findings about using this. We looked at establishment. We looked at fertilization when turf is irrigated from drip emitter. We also looked at what about combining subsurface drip with saline water. What's the issue? Salt accumulation in the root zone. Can you flush salts? And this is kind of how we designed our system. We went with the very common approach that's recommended almost on all soil types, and regardless of which type of grass you're growing, warm season, cool season, whether you do Bermuda grass or Kentucky blue or tall fescue, doesn't really matter. We placed the drip lines about 4 inches below the surface, and we put the drip lines about 1 foot apart between the drip lines and 1 foot apart between the drip emitters. And that's the common approach and has worked for us regardless of the soil type and regardless of the grass. I mentioned that. Then usually those drip systems are low pressure systems, so most of the times you need a pressure regulator. In our case, we put it down, we regulate it down to about 30 psi. Also very important, I'll get to that in a second, filter. Regardless of what type of water, groundwater, surface water, potable water, city water, you always want to put in a filter. And then on the other end, you have what's called an air release valve and a flush valve. So this is our typical emitter spacing, 12 inches. We go with emitters that are 0.53 gallons per hour. That's our emitter flow. 0.53 gallons per hour. And then by using such a spacing, here we have 35 psi on the 0.53 emitter, we can run 282 feet of drip line on one zone if we have these parameters. If the parameters are different, then it changes. If you have higher inlet pressure or a greater flow, then you can go with a larger area. But all these companies that are just mentioned at the beginning have information based on their specifications, and you just follow these, and you really don't have to be a rocket scientist to put a system like this in place. I mentioned the flush valve here on one end, and I also mentioned the air release valve. Air release valve is usually put in. You want to avoid any air pockets to build in the middle, because that then prevents your water flow. So you want to de-air, particularly as you have the larger areas. You want to de-air the system slowly at the beginning. That water then is distributed evenly on your drip lines. Flush valve, that's something that you can see it here. You can see it here in place. Is a valve that has a membrane inside, and as your system is not fully pressurized, that flush valve stays open. And if, let's say, there is any sediments, any buildup inside, it actually flushes out. You can see it here, flushes out. And as the system slowly pressurizes, then that membrane closes, and water is being released through the drip emitter. So that's one important factor. Some of the main benefits, I mentioned that you can actually irrigate whatever area you have. So we see one of the biggest markets right now for subsurface drip is on golf courses, on bunker surrounds, where you have where it's very hard to irrigate these steep slopes, or they would have to be hand irrigated, and that is very costly. If you had a sprinkler up here, then there would be overthrow, and then the sand would wash down, it has to be raked up. Yeah, that's why we see a lot of subsurface drip on golf courses. As I mentioned earlier, we did some studies. Here is just one photo of a study we did a few years back and was published. We had 3 years of potable irrigation at 50% ET. We had warm season grasses. And you can see here on the left side, this is drip irrigated turf over 3 years, and this is sprinkler irrigated turf. Warm season grasses at 50% ET. So the quality, you hopefully will agree with me that the turf quality here is greater than what you see here. I have a colleague, Matteo Serena, a colleague of mine. He wanted to push this further, and last year we went it down to 10% of ET, and we put out drip irrigation and sprinkler irrigation. Now this will probably most likely never be published, because a study like this comes across as being unreasonable and just unbelievable, because we don't have, I mean, we tried to irrigate at 10% ET, and after 4 months into our study, we had to terminate because we have lost our sprinkler irrigated plot here, whereas the drip irrigation still kept on going. Now there's a few issues that, or a few factors that need to be considered here. First of all, we irrigated Bermuda grass, and Bermuda grass is a very drought tolerant. I'm confident, we've never tried, but I'm confident you could not do this with tall fescue or Kentucky bluegrass. The other thing was that last year when we did this, we didn't had a lot of rain, but any rain we got was perfectly spaced. So these rainfall events were perfectly spaced, which helped the drip irrigation to survive, and a very drought resistant grass will benefit from these equally or evenly spaced rainfall events. So this need to be said here, but overall that ties into all our findings that subsurface irrigated turf is more drought resistant and can sustain on less water And one of the reason for this is that if you work with low amounts of water, or I should say lower amounts of water, it is better to place them directly at the root zone so you don't have any additional losses. Whereas if you use a sprinkler system, you throw the water first in the atmosphere, you hope that it lands on the area that you want it to land. It still has to trickle through or to percolate through the turf canopy, then through the thatch before it even reaches the roots. And there is definitely more losses along the way, which you just don't have when you drip irrigate. So your water use efficiency on drip irrigation is higher than it is on your sprinkler irrigation. A few years back, we had actually a fairly wet summer, which at least for us, and we saw brown patch on our cool season grasses. And interestingly, that brown patch was predominantly on our sprinkler irrigated areas, but not so much or almost non-existent on our subsurface drip irrigated plots. And this is something we know from production agriculture, that if you spray irrigate or if you flood irrigate, you have a much higher disease incidence, and that's been reported, than you have on the subsurface drip, because with subsurface drip, you keep the canopy just drier and the fungus doesn't have the microenvironment to grow actively. Here are some examples how we put subsurface drip in the ground. This was a larger installation where we worked in Albuquerque on a soccer complex, and they brought in the big plow. Of course, at plot size, it's all manual work. Here you see the header line, and then here you see the drip line connected. We also work with a trencher if an area needs to be retrofitted. But that's this is how it will look at the base in the residential landscape. In the urban landscape, we see this is how it's, if it's done, this is how it's done. So you place it on the subsoil, and then you come in and place 2, 3, 4 inches of topsoil on top of your drip line. I even have contractors that would place the sod right on top of the drip line. Not recommended by us, but that's how they do it because it requires the least amount of time. This here is an example of a workshop we did 2 weeks ago here in Las Cruces with master gardeners, where we put in a drip system at a middle school. So here is the school building here, and here the kids come out, and there was this long and narrow area that just was perfect to put in a drip system. And you can also see that the soil level right now is below grade, so we could put the drip lines just on the surface, and then the contractor came in and finished for us and placed 4 inches of topsoil on top of it, and then sod was placed and or will be placed. I think they're still working on it because that workshop was just 2 weeks ago. Here is an example how to retrofit an existing turf area. We have kind of an oddly shaped landscape here, turf area. So we actually work with a flexible 1-inch flexible tubing here, and we use these type of connectors. They are called blazing saddles. They clamp on this on the flexible tubing, and then you screw this connector in. It pokes a hole into the flexible tubing, and with the pressurized water, then the water pressurizes the system, it seals it, and then comes a connector for the drip emitter. So here you see this is the trencher we used, and here are the trenches for the drip lines placed after the fact, after the turf was already established, and the owner decided to get rid of its sprinkler system and put in drip system instead. This is how it's connected. So here we have our 2 zones for a backyard, and we have a pressure regulator and we have a screen filter. And I mentioned that earlier. Screen filters are very important for a drip system because anytime you get something into the line that you don't want into the line and they clog your emitter, that is near permanent, particularly if you have sediments or very small gravel or pieces of rocks, whatever. Once they get into the drip emitter, you can't flush them out again. If this is a big issue, you actually have to go in and cut the piece out and put a new piece in. This is something, it's very common on screen filter. Every so often you have this buildup. It's kind of an iron-based buildup, and then the screen filter need to be washed. Has to be part of the maintenance of your drip system. And then we here put them either in CLR, or you put them in vinegar, these screen filters, or any similar product, and cleans the filter, and then they're ready to go again. On the large scale, this here is a photo of our research site where we have 2 acres under drip irrigation, and we work with the sand filter because we have saline groundwater that we pump, and that not only needs to be filtered for the drip but also for the sprinkler system. And we have a commercial grade sand filter here in place that we have to back flush every so often to get the sediments and all the debris out that is could cause issues on our irrigation system in general. No system is perfect. Neither is Subsurface Drip. Here are some issues that we've come across over the years. This here is a kindergarten in New Mexico where the parents put the drip system in the ground themselves, but they didn't have enough pressure or flow for their zone. So you have grass growing mainly on the lines, but you just don't have enough water to also distribute evenly in between the drip lines. This here is tall fescue growing on drip lines where the drip lines were placed too far apart. So the grass grows happily on the drip line and next to the side, but not so much in between. So in this case, it wasn't 12 inches or 1 foot weren't followed properly, were too far apart. Wanted to save some money, and then we have issues in between the drip lines. Root intrusion can be a problem. That's just an example. It's not that these photos here have caused any issues, but there can be problems, particularly if you use a product. If a drip line is used that it is not recommended for the use of turf. When we talk turf and subsurface drip, we usually talk permanent ground cover, so we have to use a much sturdier and a much more expensive material than we would use for some row crops or field crops where we also do crop rotation. And these drip emitters, particularly T-tape, is commonly used in agriculture, but it is not recommended for the use of turf. But these T-tapes are significantly cheaper. The main companies that offer products for turf have make some kind of adjustments. For example, Toro has Treflan incorporated in the plastic, and that is patented. And Toro, if I'm not mistaken, warrants it 10 years or 15 years against root intrusion. So the Treflan in the plastic prevents the roots from growing in. Rainbird and Netafim have taken a different direction about 2 years ago, and they started incorporating copper into their drip emitter. And copper is also known in small, low concentrations to be toxic to roots. So these copper-infused drip emitters are supposed to prevent root intrusion. That's what the manufacturers at least say. We don't have much experience with these 2 newer types just yet. Now, of course, systems can also fail because they are not installed properly. Here, for example, we have this was in one of the Mediterranean countries that came across where they have subsurface drip that then actually was exposed to the surface, and this was supposed to be the header line, but the header line can never build up pressure because it's open on one end. So same here now, wasn't installed deep enough, so also caused problems. That was an interesting problem we came across a few years back. This was a 5-acre soccer complex that was put on subsurface drip, and the manufacturer delivered a product in which the drip emitter didn't work properly. You see here, water comes out as almost like a gushing, a streaming. That is not how it's supposed to be. And when we investigated further and sent in samples, they discovered that all drip emitters were faulty. So they had to remove on that soccer complex 5 acres of drip lines that were already placed in the ground. Not a good thing to do. This so this subsurface drip irrigation has been on the market, I mentioned, and just been used on golf courses, maybe on bunker surrounds. But with the more recent droughts that we have been facing in the Southwest, there has been a little bit of a change in perception, and we now have superintendents that are also looking at subsurface drip, not just for their bunker surrounds, but also for some other areas on the golf course, strictly for water conservation purposes. So here is one example that we've been working with for 2.5 years, a golf course in New Mexico, Las Campanas, which is up north in the Santa Fe area, and they've had issues that their sprinklers just irrigated too much turf, and or too large of an area. So they had all these, they started growing desert in an area where they didn't want it, which caused maintenance issues and budget issues. And they came to us and asked us if we were interested in conducting a project, doing a project on the golf course by looking at subsurface drip on these tee areas. And also the USGA agronomists came on board, and we submitted for a grant, which was awarded. So we went out and put 12 tee boxes on subsurface drip irrigation, and we had all four big players on board. Here we have a tee box that the sod was removed, it was trenched, and we put in a rainbird system. Here we trenched into existing turf and we put in a Toro system. Here also sod was removed to trench into the subsoil, into the root zone. And this is the Netafim system. And here we have the Hunter system that comes with the fleece. So we have all 4 of these systems in 3 tee boxes, and we're gonna monitor the performance over the next over the next 3 years. Sorry. There's just some photos here. Clearly, from a golfer's perspective and installation perspective, it is advantageous to remove the sod, put the drip line in, and put the sod back on, because the surface heals much quicker, and you don't see the installation 2 weeks after. Whereas when you trench into existing turf, cool season existing turf here, it takes much longer. So this was placed in April, and in August the trenching is still visible, whereas on the sodding side you don't see any patterns anymore. Also, One other thing to watch, after we left, the golf course took over and put what was remaining, they put it in themselves. And then the drip lines were placed too deep. This is a very sandy root zone, a very sandy soil. And if the drip line is too deep, particularly after installation, during establishment, during recovery, the capillary raise just doesn't get to the roots. So we saw issues, we saw problems, and then they had to go back in and actually dig up the drip lines and bring them closer to the surface. And we see here in time, we see some healing now that our drip lines are at the 4 inches, at the recommended 4 inches. This is kind of a time lapse through the year on these drip irrigated turf areas. You see March where ET is low, so the water amounts are also very low. You see the striping, interesting, but as ET goes up, your irrigation amounts go up. And by July, August, you don't see the striping anymore. Also very noticeable here is that we're now irrigating exactly the area that needs to be irrigated. So there is no overspray anymore, and you can actually leave the areas outside the tee box as a desert, in a desert landscape, the way it was designed originally. Water use, first year after establishment, we saw a reduction in water use by 50%. However, this is not so much because we're delivering water efficiently on the grass. It's just we cut out all the areas that that didn't need any irrigation. That's where we see, and that's why we see the water savings, 50% the first year, but we keep going. The reason why we know 50%, each of these tee boxes has now its own water meter, and we record water usage on a monthly basis. So we have gallons applied per surface area. Also, each of these tee boxes has a screen filter I mentioned earlier that needs some attention, particularly as you fire up, turn on the system after the winter, when the system is turned off, and they pump both groundwater and use surface water, so there is always something in the water that is not supposed to be there. That here, the lower right photo, even though we placed it deep enough that core aeration would be possible, the superintendent still is hesitant and has not core aerated since, but also at least he told us he didn't really see a need to core aerate these tee boxes. Now they still wanted to make sure that the crew, when they go out and aerate the other areas, that they stay off these tee boxes that have drip irrigation. But when they placed the sign, they actually poked the 2 wires that they used for the sign. They poked 2 holes into the drip line, which had to be repaired. Quite funny, I think. Last but not least, our project up in Albuquerque. I mean, we've documented that subsurface drip irrigation works perfectly on smaller plot size, on tee boxes. We still also always like to upscale. Here we have a 1.5 acre park in Albuquerque that was split in half, where the Park and Rec department worked with us, was split in half, and 1/2 was put on subsurface drip. The other half stayed on sprinkler irrigation. Working with Toro here, and a landscape contractor that put the drip lines in place for us. And after 1 year, we saw water savings in the amount of 30% on the drip system compared to the sprinkler system. So in conclusion, I feel comfortable saying that subsurface drip can certainly be used to irrigate turf efficiently, also in combination with saline water. It is a viable alternative to what we are currently using, but there is certainly also needs to be installed properly, but you also have to monitor and maintain properly. And also we just need more education and public outreach to see more of that go in ground, as we strongly feel that it is a viable alternative. I want to acknowledge all the companies, associations that have supported us over the years in our efforts to keep grass green, even in a desert environment. And with that, I have a few questions for you that I'd like you to answer. There are 3 survey questions, and also I open it up for questions.
Alrighty. I'll go ahead and launch the poll, and folks can weigh in there while we're waiting for questions. Bernard, I'm curious about if there's a new installation. You had some pictures of golf courses, even like soccer fields and those things.
Mm-hmm.
Would they generally go ahead and dig that out down to whatever level and lay the lines and then come back in and put field dirt on top of that? Or would they sort of do the landscaping and then come back and trench that out and then lay lines down? What's the most efficient or
on the bigger athletic field? Athletic field use and park size, they usually have these agricultural type plows where they have 3, 4, 5 rows of drip irrigation on the back, and they just pull it into the existing ground. Gotcha. On the smaller areas in the residential landscape, homeowner where we talk 800, 600 square feet, the landscape contractor usually just removes the dirt, puts the drip line in, and then puts the dirt on back on.
Can you drive on top, like in a situation like that where they've removed dirt and then they put the lines down when they're going to put the dirt back in? Can they use a piece of heavy equipment to sort of put the dirt back? I mean, is it okay to drive on top?
Well,
of it?
Yeah, if you put the 4 inches on that are recommended, and you kind of work forward, so you always put dirt on, then you can with the front end loader you put more dirt on, and yeah, that's how it's done, and we haven't seen any damage by doing so.
Yeah. Okay.
Great, thank you. We did have one question come in from Rick Heffelbauer from Utah. He's wondering if the subsurface drip would be successful in a slope area.
Yeah, that's actually where it all started, on those slope areas where it's just impossible to place sprinklers. That's how it all started. That's where we still have our largest areas, and where it has been most commonly used. Those were those steep sloped areas on bunker surrounds. That's how it started in turf, I should say.
But are there any limitations on slope? Like, what's the steepest slope?
I can't give you a number, but I have seen some steep slopes where they just ran the drip system across the slope, and it worked much better than what they had before.
Yeah, golf, I know you had pictures of golf bunkers there, and the slopes can be relatively steep there, although they're not terribly long, but they can definitely be steep.
So if you wanted to, if this was a new lawn and you were putting the subsurface in and you wanted to establish the lawn through seed versus sod, is that an option, or would you need to bring in sprinklers to get it started?
We've done 3 studies where we compared subsurface drip to sprinkler, and on the subsurface drip we did not put any additional sprinkler on top of it. If your soil type allows for the water to wick all the way up and you see the wetting front on the surface, your grass will establish. But in all our studies, the sprinkler irrigated turf established faster. So you have a head start by placing water on the surface. So if time is of the essence and you want it established from seed, place a temporary sprinkler system on top. That's how they did that soccer complex that I showed. They moved sprinklers around just to get it going from seed. On sod, it's exactly the same. We had the drip system, we placed the sod on top, and not using any sprinkler will establish your sod. You will develop your root system, but you can see a little bit of pattern, dry pattern on the sod when when the water is not coming up immediately. So again, if time and quality is of the essence, then a temporary sprinkler will definitely help.
Great, thank you. So David Wright is wondering, he's asking, he says, it seems like a challenge to get this installed and getting the right clients who want it to be installed. There needs to be an obvious cost benefit. Without the cost benefit, our contractors won't adjust their skills to meet the demand. How popular has this been in other parts of the country?
Not popular at all. It is. There's two challenges. The point he raised, he's absolutely right. But then on cost is an issue, and in order, and those subsurface drip is more costly because you have more piping, you have more hand labor, connecting all these drip lines. That's all hand labor. That is more expensive. But even if the homeowner were willing to pay the extra cost because they say, I want to be a good steward, I want to use as little water as possible, yet I still want to keep my grass, it is hard to find a contractor that will do it because we have this emotional and philosophical attachment of our contractors that water has to come from above, at least when it comes to turf. And we have contractors here in town that will talk you out of it. They and use a long list of arguments, are just unwilling to put it in, even though they put the same system in the other part of the landscape, under shrubs, in flower beds. It's just this. Yeah, we have to overcome, but then there are we have subdivisions that mandate subsurface irrigation. So once it becomes, when you put in a new house and a new yard, and then the additional cost actually becomes hidden in the overall price of the house, it's not so much of an issue. But then once you want to put it in after the fact, the price is an issue. Now California has even gone one step further. California now mandates subsurface drip irrigation per statewide ordinance for anything that's narrower than 15 feet, because we don't have a sprinkler that can throw less than 15 feet, and also for extremely irregularly shaped turf areas where it's just impossible to keep the water on the grass, where you would have to face significant overspray. Those are the two requirements where subsurface has to go in.
Not seeing anything in the chat box. Our next webinar is coming up on Tuesday, July 10th. We have Kelly Cope from Utah State University sharing some of her experience in collaborating with the industry and working science into their conservation methods. So I'll send emails out to all of you with that information, and thank you for joining us, and thank you, Bernard.
Thank you for having me. It was a pleasure.
Thanks folks. Bye-bye.
Bye.